All right. Hello, everybody, and welcome to the stream. I hope everybody's doing well tonight. We're going to be trying a couple of new things tonight just to see how things work. For one thing, I finally got a bot working over on the YouTube side, so we are multi-streaming both here on Twitch and over on YouTube. So I still have to manually enter commands over on the YouTube side, but at least the bot's hooked up. So I think we should be good to go. All right. Before we jump into what we're going to work on tonight, I do want to take a quick second and just thank the supporters of the channel, beginning with the partners at the top, which are Arslia and Gerboles Inc. Our partners are the top tier of subscription over on Patreon and YouTube memberships. And I'd also like to thank all the other supporters listed here on the screen. They are Twitch subscribers, supporters on Patreon and YouTube on the other tiers of membership that are not partner. So thank you all to you very much for your support. I greatly appreciate it. I'd also like to thank all of the viewers here, whether you're here on Twitch or on YouTube, for your support and just being here and interacting. I appreciate you guys. And yeah. So thank you for being here. Obviously, this stream would not exist without you guys, nor would this project, right? So, all right. With all that said, this is designed to be an interactive stream. So please feel free to jump in and interact as much as you want. I do keep an eye on both chats. So if you guys have any questions about what I'm working on, or you have any things you want to discuss, feel free to jump into chat, as long as it's reasonably related to what we're talking about here, and obviously respectful and all that. We're good to go, right? So all right, so between the last stream and this stream, we've gone ahead and done quite a bit of work. So I'm actually just going to quickly build. And basically, there's been a list of changes, actually, that have been made since the last time. So we're going to kind of step through those now, as well as some concepts and things that we're going to talk about in terms of clipping. So one thing that we are going to talk about tonight is, and I'm actually going to try using my tablet to explain this, see how well this works. So one thing that we want to talk about tonight is something known as a stencil, right? Stencil, right? And so what a stencil is in graphics APIs is you essentially have a area of your render target that you designate to be drawn in. So that can be a circular area like this. It could be, a triangle. It could be a square, whatever, right? And the idea is that if you have an object that partially interacts with that, like let's say you have, for this square right here, you've got, a circular object, right? That sort of looks a little bit like this, right? And so part of it overlaps our sort of stencil area here, is what we're calling our stencil area, and part of it does not. And so what we can do is something called stencil testing, which means that anything within that stencil area gets drawn, right? So that would be all of this would get drawn. And anything that is outside of that stencil area, that would be all of this, does not get drawn, right? And so the good thing about this is that we can use this to actually clip our text in our text box. And these stencils can be drawn in any shape, size, orientation, what have you. So if you had a rotated box, you could draw it at an angle like that, right? And so stencil buffers are extremely useful for basically plotting out a section of the screen that you want to draw to. and then not drawing outside of that sort of stencil area, right? And so the advantage over something else that we know as scissor, which we've already seen in Vulkan when we set the sort of scissor area, is scissor is bound to the axis, right? The X and Y axis, right? So you can't, scissor cannot do this, right? It cannot do that. It can only be bound and straight like this, right? It can only be a rectangle that is axis aligned, right? So you can't have anything like this, and you can't have anything like this, right? And you certainly can't have this. You can only have something like this. So the advantage of a scissor is obviously it's much faster because you're able to essentially just clip out a portion of that image. Right now, it kind of works the same way. So anything that is drawn in here or is inside that scissor gets drawn, right? And anything that is outside that scissor area is not drawn, right? And so, this is faster, right? This is slower, right? Sorry about my terrible handwriting there. So that's a minus for this side and a plus for this side, right? But a minus for this side is it has to be axis aligned. And it has to be a rectangle, right? Versus this side can be, we'll say arbitrary orientation, right? And this can be any shape, right? If we wanted a stencil that looked like a circle inside a circle, right? Where we only wanted this section here to be drawn, right? We can actually do that. And that's a common technique. You'll see it in like health bars and stuff where they have sort of a circle that gets drawn for your health bar, right? That's kind of something that you see for that, right? So, yeah, I hope all that makes sense. And that's kind of what we're going to be implementing tonight. iDog. Yes, finally caught a stream. Welcome to the stream. Alvaro, good to see you again. Welcome, welcome. Hope you guys are doing all right tonight. So, yeah, we're basically just talking about what we're going to be implementing tonight. This is, well, technically it's already implemented, right? Because this took a lot of trial and error off camera and was something I really didn't want to putz around with too much live, right? So I did already implement this, but as it turns out, we were like 95% of the way there already with all the Vulkan setup that we had already, right? So there's actually not a whole lot that we had to actually do to get this to work. It was mostly just plumbing in a couple of pass-through functions and things like that. So nothing too huge. So with that, I'll leave this here for a second, I guess. Let me actually pull up the commit for this. There's a bunch of changes that we're actually going to look at, but for now, we're going to focus on this one and then go into the other stuff before, or afterwards, I should say. So let me see. Let me just pull up the right one here. Here we go. Okay. So, we can see here, we added support for stencil buffers and stencil testing. That's the thing we just kind of talked about. We added support for toggling key repeats on and off. I did that so that we could actually navigate within the text box. And then we added standard UI clip masks, right? And a clip mask is basically a wrapper around this guy, okay? And so some of the changes that we had to make right off the bat were to our standard UI shader. So we made sure to not cull any geometry, at least for now. And then we added a couple new properties. So we have stencil test and stencil right? So similar to how we have depth test and depth right, we now have that option for the stencil as well. We added something to our event to count keyboard repeats, key repeats rather. And so what we're doing is we're essentially taking the key repeat control away from or out of the platform layer, and we're going to handle that in the input layer instead. So I've already made these changes for Windows. I'll have another couple commits that I'll have to make for Linux once I actually happen to boot up and get over on that side. But that's kind of the goal that we're going there, because we want key repeats when we're dealing with the text box, right? So if you hold down the A key, you want it to keep typing A, right? And that's what those repeats are going to give us. So we have a new configuration option in our input, which is allow key repeats, and we can turn that on and off by a function that we've added. So we have a default of false for those key repeats, and basically anytime we focus a text box, we're going to turn those key repeats on. And then when we unfocus the text box, we'll turn them back off. Okay, so in this case, we had to change up our logic a little bit here. So we were saying initially we only want to handle the event if the state actually changed. Well, now that's true, but also if we're allowing key repeats, then we also want to handle those as well. So if we allow key repeats, or if we don't allow key repeats, but we have an actual change, then we go ahead and do it. We go ahead and we put in is repeat here. Nemeth, thank you so much for the follow. I appreciate that. Welcome to the stream. And so we basically put a 1 or a 0 for key repeats here for right now. Eventually I'll pipe that into how many times we've repeated that key. But for right now, at least we have something plugged in there, right? So we can truthfully look at this and say, okay, if this is 0, then that means it's an original key press, right? And we can actually handle that at the event handling layer, right? So we added this new function here for key repeats enable that just toggles our internal property. Here is the header version of that, right? So nothing overly complex there. So let's just minimize these guys, right? So when we're talking about the stencil buffer, there's a few pieces of our dynamic state that we are going to have to change. And so we need the ability to set stencil testing enabled. So once we have that stencil, right? Once we have a stencil defined, we need the ability to test things against it to see if it should draw. And so in order to do that, we need the ability to toggle stencil testing on and off. We need the ability to set a reference. So if we just had a single sort of version of this stencil, right? What if we had ones that overlapped? Like, what if we had another stencil that was like maybe here or something, right? And we didn't necessarily want to include this section of the geometry down here because this is a separate stencil, right? So what if we only wanted to include this part, right? If we only wanted to include, I probably should have chosen a different color there. Let's go with orange, right? If I only wanted to include this section here, right? Because that's on our new stencil, that's here, this guy. Then we need some way to differentiate one stencil from the other, right? And that differentiation is what we call a reference. This works the same way in OpenGL as it does in Vulkan. There's an internal reference ID that we use, and that is basically stored in the image data that is the stencil buffer, right? And we'll take a look at what that stencil buffer looks like here in a bit. So the important thing to note is the reference can be a value from within the range of 0 to 255, right? Because it's an 8-bit, it's an 8-bit image essentially. Okay, so that's what the stencil reference is. We have the ability to turn on and off depth testing. So we may want to turn that on or off when we're doing stencil testing. So we have that ability if we need it. We also have the ability to set the operation, right? And so there's a couple of different various pieces here. And so we have the fail operation. So in other words, what to do if the stencil fails, what to do if the stencil test passes, or what to do if the stencil test passes but the depth test fails, right? This, I believe, is that they both pass. I put comments in here. We'll see that in a second, right? So we basically have these different conditions and what to do in each. And then we have the comparison operator, which we'll get to here in a minute. And all of these functions, by the way, just pass through to the backend, right? So a lot of what we've seen here is just going to be implemented at the plugin level as well, right? So these just pass through. We have a compare mask, which can be used to set a value from 0 to 255, right? Most of the time, you don't need to mask anything out. You could just use one or the other, right? Either 0 or everything, which would be 255. And our right mask is also kind of the same deal, right? It's an all or nothing. So if you pass 0, that means nothing gets written. If you pass 255, that means anything that you try to write to the stencil buffer will always be written, right? And so that is what all of that is. That's sort of the front end of that. It's just a bunch of pass-throughs, right? And on the front end, I went ahead and detailed all this out in comments, right? So it's very clear as to what's going on when you call this stuff, right? So, let's see. Ad Libya. Hi, this is my first time seeing you in a stream finally. Awesome. Well, welcome. Welcome to the stream. Good to have you here. This is an interactive stream, so if you guys want to chat a little bit or you have any questions about what we're doing as we go through, feel free to jump into chat, right? And I will keep an eye on it to the best of my ability. Sakelos Music, hello. Welcome to the stream. How are you doing? So I am reading both chats at once. I've got sort of YouTube chat here and Twitch chat down here, so I can see both at once. So, all right. So these are all the sort of exported interface points from the renderer front end. Renderer types. This is where we have defined our additional plugin methods as well as our stencil operations and our render compare operations. And so these are what was required by this function, right? This set stencil operation, right? And so basically, you would say, well, do we want to keep the current value? Do we want to zero out the current value? Do we want to replace it? Which replace is that uses that reference value that we set before, right? So we have this set reference here. That number is what is used when we use replace, right? Increment and clamp increments that reference value and then clamps it. Decrement obviously decrements that value and clamps it to 0. Invert basically just does a bitwise, it flips the bits of that reference. I'm not sure why you would ever use that. I've never used it, but it's there, right? Vulkan and OpenGL both support all of these things, right? And I'm pretty sure DirectX does too. So we're trying to be as generic as possible, right? We have our own types exposed here that the renderer knows about, and then we just kind of convert those on the back end, right? And then we also have increment and decrement that wraps around. So instead of just clamping that value when we increment it, if we reach the end, we just wrap back around to 0. Or if we're decrementing and we reach 0, then we wrap back around to 255, right? And so that's how all those things work. And then our comparison operation. So never basically means that it always will fail. And then you have less than, equal, less or equal, greater, greater or equal, not equal at all, or always, right? Which means it's always true. So you can combine these and these to determine what to do when you're reading and writing from your stencil buffer, right? And that's kind of how the GPU knows exactly what we want to do with it, right? So we just use different combinations of those to get what we want. Here's all the plugin interface points for all those things, right? So that's what we've already gone over. There's nothing else there. So that is that. The render graph had a small fix that we needed to do. So we were doing some checking here against the attachment source type. And the attachment source type is actually a bitwise field, right? So realistically, it should only ever equal color, right? But theoretically, it could also be ANDed with depth and stencil, right? So we check those things separately here. And if we do, we return the depth attachment. This is not an accident, right? So basically, with your depth, your stencil, your depth stencil attachment rather, you have an image, right? A 32-bit image where each channel of that is 8 bits, right? And so 3 of these are for depth, right? And so far, that's all we've been using. But we actually have another 8 bits here, a 4th channel that is our stencil. And since this is 8 bits, right, that's why we have that 0 to 255, right? And so I hope that makes a little bit of sense, right? So with all that said, this is what that is checking for, right? Commonly, you can have a depth and a stencil attachment, and they're the same thing, right? Or you might have one or the other, but either way, we're going to use that depth attachment, right? So we have that. The shader loader, we've added an additional thing for stencil test, right, to read that in. So we've just added that. Geometry system. So, okay, I didn't realize I made this change with this change set. I thought this was separate. Okay, so one thing that kind of got in the way of what I was working on was the concept of, we had this material and then we had this sort of UI material thing going on, which we didn't really ever wind up using, right? We had one object that ever used it, and I said, we're going to kind of get away from doing that. And it was a lot more than it was worth to try and make that work with these changes that I was making here. So this change set also does away with the default 2D geometry, the default UI material stuff. That is all removed, right? We weren't really using it anyways, and we were able to just eliminate a lot of complexity, right? And so this is just removing that stuff out of the geometry system. And again, we can see here our UI shader, right? That all that stuff is removed. Our default UI material, all that stuff is removed, right? And so the creation of all that stuff is all removed. We also don't have a default UI material name anymore, things like that, right? So that's the removal of all of that stuff. So that's material system, geometry system, and material system, right? So we've removed all that. The shader system, we did update the shader flags, right? Because before all we had was none, depth test, depth right, and wireframe. And so we've added to that stencil test and stencil right. Okay. So there's that. And let's see. This is just version. That's no big deal there. So we have made a number of changes to SUI Textbox. I'm going to come back to that, right? Because we're kind of talking about renderer stuff. So I'm going to skip over implementation stuff, or I should say consuming stuff that's using this stuff. I'm going to kind of skip over that for right now. So this is the H file for that. UI pass received some updates as well. So our You know what? Yeah, this is fine to go over. So UI pass, instead of clearing nothing, now clears the depth and stencil buffer. And then we also have a new attachment to that pass. So that's our depth pass, right? And the important thing to note here is the type of attachment is depth ORed with stencil, right? Because we want both. So that's our depth stencil attachment. We changed from built-in UI to standard UI. Here is where we're just setting the depth test enabled to false because we're not really using that in UI anyway. And then all of this stuff here was all old rendering code, right? So we just ripped all that stuff out. It wasn't being used anyways. This was to draw like UI geometries. We're not really using that anymore, so we just ripped all that out. Instead, we're using renderables, right? And so we're using our clipping mask here. And so basically what this is doing is we are checking to see if we have clipping mask geometry. You know what? I'm going to skip this for now too. I'm going to come back to this because we haven't actually talked about some of those things yet. So I'm going to come back to this one. UI pass, the extended data for it no longer has geometries, right? That's all that changes. Okay, so standard UI system, the H file for that, now has, if we take a look at our standard UI renderable, right? This is sort of our base object, if you will. Now has a pointer to something called clip mask render data, right? And that's just geometry render data, but by default, that pointer is a null pointer, right? It's 0. And so the idea here is if we have this clip mask render data, then that means we have a clipping mask attached to the thing that we're trying to render, right? And we should process that. Otherwise, treat it as normal, render it, move on. And so that combined with this SUI clip mask, this clip mask has a reference ID, which is used with that reference that we talked about earlier. It has its own transform, so we can transform it at will. It has its own geometry, which is very, very small. It's just typically a quad, but it could be anything, right? Maybe you want to render a 3D model and then use the render of that 3D model as your clip mask, right? So we don't want to limit you on that, so we can take any kind of geometry there. And then we have the geometry render data associated with that clip mask, right? So yeah, that is a clip mask, and our clip mask render data is just geometry render data. So we'll take a look at in a minute to see how all that comes together, right? All right. Let's see. We've got ads coming up here shortly, so I'm going to try and cover a little bit more of this before we actually break for ads, okay? So we get rid of all of our old geometry stuff, right? All that stuff is gone, right? We added to our UI pass a new sink for depth buffer, and we added a source to that sink, and then we linked it, right? So we've just added that, updated our render graph there. And that's really it for the test bed changes, right? Is this all GPU related? Yes. This all happens on the GPU. Yep. So yeah, this is clipping done on the GPU as opposed to trying to like figure it out on the CPU. Render view pick, we just include render types and we change this equal. Again, we're just checking for depth and stencil here, right? All right. So I think before we jump into backend changes, I think we're about to have an ad break. So I'm just going to hold off just for a second, and we're going to pause the stream so that way nobody misses any content, right? Yay, ads. Yep, there it is. So for those of you who don't see ads or not being served ads right now, we'll be back in about a little over a minute. I just like to pause the stream to keep folks from missing content there, right? And in fact, one thing that I've been meaning to do is on this particular screen, I've wanted to add the camera so that you guys can at least see that I'm still here and talking, right? So let me do... oh boy, which one is it? I think it's this one. Yeah, here we go. So I'll just move this down here, right? Just so you guys still know I'm here, right? So that's good. Yeah, let's make it a little smaller, I guess. I might have to reformat that screen. We'll see. All right, cool. So we got about 30 seconds of ads left, and then we'll be able to continue, right? So those of you on YouTube, the ad situation is a little bit different there. You may not even be getting them at all, but on the Twitch side, we have sort of scheduled ad breaks that work, or that run, right? Okay. We are back. Let's see. Probably heard this before. Elite Stumper. Let's see. But what's the Vulkan game engine? So, Vulkan is the rendering API that we're using in the back end, right? So you have OpenGL, DirectX. You may have heard these things before. Maybe not. But that is what interacts with your graphics card to actually perform the drawing operations on the screen to allow you to see the scene within a game, right? And we're just we're building a renderer around Vulkan, but a game engine is much more than that, right? It's a lot of other moving pieces and things like that. And so that's what we're building here. We're building an entire engine from scratch, right? Yeah, you use Vulkan in Blender, right? So instead of an application like Blender where you're using that to sort of edit geometry and things like that, we're building this into a game engine that you can use to actually make games with, right? So I hope that makes sense. Glad to see somebody who actually stops their content when ad starts. Yeah, I try to. But, some people like it, some people don't. But I tend to err on the side of caution just because I don't want folks to sort of miss what I'm talking about on the screen because it's code. And missing that stuff isn't very good when ads are running, right? All right. Let's see. So here's the Vulkan backend changes. And actually, I'm going to look at the header first so that you guys can see those changes because there's a lot of changes made in the backend. As you can see, I'm still there, right? Let's see. So here's an overview of what's changed in the backend, at least from the header file perspective, right? So these are those methods that we were talking about before that were implemented in the front end and the plugin that were just kind of a pass through. Those are passing through to these functions here, right? And so those functions here are going to be the ones that we're going to take a look at. But we've also done quite a lot of editing of other things within this file, right? And some of this stuff is just formatting changes and some of it's brand new code. So we'll kind of just step through it really quickly, it looks like a lot, but I promise, like, once you get past the conceptual stuff, it really is not that bad. So the first thing that we're going to do is take a look at when we begin the rendering. The first thing that we do is we set the stencil reference to 0. We set the compare mask to 0xFF, which is 255. We say set the stencil operation to keep, replace, keep, and always, right? And so basically what this means is we're keeping, this should probably be keep all the way down because that's kind of the default, right? But we're basically saying if the stencil test fails, leave what's there in that particular pixel or fragment as it is. If it passes and the depth test passes, then replace it with the reference, right? If the stencil test passes but the depth test fails, then we want to keep what is there. And then we always want to perform this operation, right? And so we could probably edit this a little bit and fix that. But for now, that's what we're rolling with. And so we set stencil test enabled to false. We set depth test enabled to true by default. And then we disable stencil writing by setting that right mask to 0, right? And that's kind of how that's what we kind of mentioned there. Okay, thanks for the information. Okay, cool. Glad that made sense. What does stencil mean here? So I'll briefly just kind of go over kind of what we're implementing here, right? So this is kind of my poopy drawing that I put together before, but right, let's say that we have we want to clip the contents of something on the screen, right? We only want to draw within a certain area, right? So you can take this square right here as that area. Like, let's say that that's, we only want to draw within this particular square on the screen, right? But we have an object. You know what? Let me just do a new drawing here. So we've got this right here. We say we only want to draw within this square, right? We don't want to draw anything outside of the square. We want to clip to within that square. And let's say that we have geometry. That's something like that, right? And so basically what we're saying is what we want is this section right here, right? And then what we don't want is this section, right? We don't want that, right? And so this box right here is our stencil. And when we do a stencil test, when we're rendering, we say, okay, what is inside of this particular stencil that we have drawn here, right? What is inside that? Go ahead and draw the thing, right? Anything outside of that is not drawn. Now, that's an oversimplification because we can actually invert that process too. We can technically say, okay, well, maybe we don't want to draw this, but we do want to draw everything outside of it, right? Stencils work both ways, right? So it's easiest to think about it in the first example, but yeah, that's basically how it works, right? So it represents the player's FOV. No. So think of it more as, probably the easiest way to visualize it is to think about the stencil as within the context of the flat screen, right? So let's say, for example, I wonder if I can even undo this to like clear it out. Probably not. Nope. All right. Let me start over here. So let's say, for example, you have, and the reason we're implementing this actually, right, is you have a box of text on the screen, right? And so we'll say that this whole area is your screen, right? Obviously, this is not to scale, right? But this is your flat screen that you're looking at. We're drawing the UI to that, right? And let's say that we've got some text here, right? But ordinarily with text boxes, you only want to draw what's inside the text box, right? You don't want to draw what's outside of it. So in this case, we don't want to draw this stuff, right? We want to clip that. And that's what we're using these for. And you can do this to anything with on the screen, right? So you can have, if you wanted a health bar or a health, an example that I used earlier is a lot of times you might see games will have like something up here in the corner that looks like this for a health bar, right? And obviously this is a poor drawing, but whatever. I think you get the point, right? And so your health bar sort of fills and depletes, but it only kind of goes around in a semicircle like this, right? Well, the way that that's actually accomplished typically is with stencils, right? So you might have a stencil with a shape that looks like this. And you say, only stuff inside of here do I actually want to draw. Now, what it's attempting to draw behind the scenes might actually look something like this, right? But that stuff doesn't get drawn. Only the stuff inside the template does. Or the, not the template, the stencil, right? So yeah, okay, cool. So yeah, it's basically typically used in like a screen space or an image space, right? And it's not necessarily limited to that. There are other applications where you can use the stencil buffer as well. Like when you're generating textures on the fly and stuff, you can use it for that too. It's got a whole bunch of uses actually, but that's what we're using it for, right? And the idea is that since we can rotate our text box, right, like any other control on the screen, we might have the text box at an angle like that, right? And so we can't use something that's axis aligned to clip that because that's not going to work, right? We need something that's going to wind up being able to be translated and whatnot, and that's why we're using stencils, right? So stencil is basically just used to control how things are drawn, or whether they're drawn or not. So we have a couple convenience methods in here to get the Vulkan specific stencil operation, which basically takes our generic version of that and translates it to the internal Vulkan one, right? Remember, we can have multiple rendering backends, right? So OpenGL's codes are going to be different than DirectX's codes are going to be different than Vulkan, right? And so we have to translate this internally, these generic codes, to what Vulkan actually expects, right? So we translate that to the Vulkan type. Same goes for the compare operation, right? Here is the, so these are those new methods that we added, right? So we can set stencil test enabled, right? And all this does is either calls VK command stencil test enable, or it calls a function pointer that we set up if we're loading this through an extension and it has to be loaded dynamically, right? And so we've looked at that a little bit before, earlier on in the series, where we had to do some things in terms of like if our dynamic state is only supported by extension, we have to load those up manually. That's what this is for. And we actually have some additional enhancements that come after this to simplify it. But that's what this is doing. So a lot of these follow that same pattern. This is depth test enabled. Just calls command depth set depth test enabled, right? Or the extension version of that, right? So that's what that one is. Command set stencil reference. That's that reference number 0 to 255. That one is just supported no matter what out of the box. Stencil operation is either we support it natively or we have to do it through extension. Stencil compare mask and stencil write mask are both thankfully native since 1.0, so we don't have to do any fancy checking there. We can just call those commands, right? So all those are just pass-throughs, really. All right. A lot of this, we've done a lot of condensing things to one line because our formatter went nuts at some point and started like multi-lining all this stuff, and that's really annoying. So that's all just formatting changes. This here, we have do clear depth and do clear stencil checks now, right? So we basically just check the clear flags for the depth buffer clear and the stencil buffer clear to determine what clear operations we need. And then we say, well, if we have either one set, then we're going to need to set up a new clear values, right? This is kind of the same as before. It's just instead of only taking in depth like we did here, we can take into account stencil, right? And so we have that. And then here is where we actually set the value for depth, right? So if we have, oh, you know what? We're clearing depth always, aren't we? This should probably do what this does. Not a huge deal. We can fix that, but so we basically set the depth clear value here, and then the stencil clear value here, right? We do that basically by saying, are we clearing the stencil? Then use the stencil clear value that was provided. Otherwise, use 0, right? We should probably be doing that same thing here. So I should fix that. And then here, of course, again, is one of those checks where we are checking for attachment type. Now we check for attachment type depth or stencil, right? This is a formatting change, more formatting changes. These are formatting changes. Same as that. I think all of this stuff is actually, all of these are formatting changes. Okay. Yeah, these are all formatting changes as well. Here again, we're just checking for the additional type of attachment type, right? So it could be depth or stencil, right? Codespace25, hello, first time chat. Welcome to the stream. How are you doing? I think that, yep, that's just formatting change. A lot of this stuff's just formatting changes, right? We separated out the load operation for depth versus stencil, right? So we just have a little bit of separate logic there. And basically what we're doing is we're setting the stencil load operation, right? So that was always set to 0 before. Now we're actually setting it to something, right? And so we do a little bit of checking here to say, well, you know, if the attachment is set to load, but then the load operation is set to clear, then that's kind of stupid, right? Why would we load it and then immediately clear it, right? So we go ahead and warn about that and then set it to clear. Otherwise, we set it to load, right? If it's not to clear. I'm good. I'm abusing the frame buffer in Linux to TTY to make a GUI in C. Nice. That sounds wonderful and terrible at the same time. But yeah, that sounds like an interesting project for sure. If only Wayland, or I should say, if only most applications worked on Wayland, I'd probably be on Linux right now, actually. I had to switch away from it because I was having issues with OBS and my GPU driver, so that's kind of annoying. But yeah. Okay, so yeah, this is all formatting changes. I probably should have separated out the formatting changes in retrospect. That's mostly what this is as well, I believe. Yep. Yeah, this is all formatting changes. Yeah, okay. So, yeah, that's all formatting. So yeah, that's basically the backend changes, right? It looks a lot worse than it really is because we have so many formatting changes. But once you get past all that, it's really not that bad, right? Vulkan device has a few changes as well. So we load a few new function pointers if we need them. So this is where those function pointers are actually loaded. If we determine that we do not have native support for this, but have to support it via extension. So that's where those are. That's a formatting change. And I think the only other thing that we wanted to do here was we had a texture format that would no longer work for our depth, right? So we were using this D32S float, which is no longer going to work for us, right? We need to actually have D32S float S8 uint. So basically the 32S float is basically saying that we have we can mix the two of them, right? Because certain operations with a stencil buffer will not work with this format here. We have to use this one. So that's that. Here is where we actually assign the support flags, right? So whether or not we have native support for some of this stuff. So this is something that I actually had to touch a couple of times. I didn't get it right in this particular commit. And I was actually able to resolve an issue in here that I didn't realize was here that was causing me to have to write a lot of other code for Mac OS that I actually didn't need. So we're actually going to eliminate a lot of that stuff. So we're going to revisit this. Vulkan pipeline. So basically we just added stencil logic in here. So we have the stencil test enable instead of being hard-coded to false. Now says, are we configured to use stencil test? If so, use true, otherwise use false. And then if we are doing a stencil test, then we set some defaults for the compare op, the fail op, depth, fail, pass op, right? And I just kind of put for reference in here for the OpenGL folks, what the equivalents are to these functions, right? And then we sort of default the right mask, and then we have the front face, but back face, right? So we have, we just use the same for front and back, right? And then we also push in a bunch of dynamic state options if we are using dynamic stencils, right? So this is actually a little bit more complicated than that because we actually have depth stuff in here as well. But this is basically what we need to enable for all of those functions that we added to flop those around in dynamic state, right? You don't like whales. I assume you meant Wayland. So I used X11. Fair enough. X11 is the old reliable, right? But like it's got its issues. Like if you have mixed DPI monitors, it's a nightmare, right? We actually ran into issues on this series with that. And I have a cat going bananas in the background. That's awesome. Okay. And so here with our depth stencil state, we basically were checking against the depth test flag. But now we also need to check against the stencil test flag to see whether or not we actually use the depth stencil configuration, right? So that's that. Not a whole heck of a lot of change there. Not yet, anyway. Vulkan swap chain, we just did a couple minor fixes here. We were calling this depth stencil image a swap chain image, which is wrong. So I just renamed that to depth stencil texture index, right? Here for the image aspect, we use depth and stencil now. So we OR those together. And then I'm passing through the formatted name when we wrap it, the internal texture with the texture system texture, right? So there's that. Vulkan types, we added a couple of dynamic device support flags here, and somewhere to hold our function pointers. We're going to revisit these as well. And then in the plugin, we just assign our interface function pointers to our Vulkan functions, right? So we just plug all that in here. And now we can actually look at the code that uses all this stuff, which is here. So we were kind of going through this file before, which is UI pass, right? And we got most of the way through it, and then I'm like, okay, I'm going to skip this section. So this is the section that we skipped. So let me expand this up a little bit. So when we are rendering, right? So this is the execute, UI pass execute, right? When we are rendering, we're looping through our renderables. We check that renderable to see if it has clip mask render data, right? And if it does, then we're going to basically enable writing and disable testing for now, right? So we're basically going to draw to that stencil buffer. And so the way that we do this is we say, okay, let's turn on stencil testing, turn off depth testing for now, because we don't need it. We're just drawing a solid color, right? And we're going to go ahead and set the reference to the reference of the clip render data unique ID. So each clip mask is going to have its own ID between basically 1 and 255, right? So we just use that as the reference, right? We have the right mask, so we go ahead and set that. So we set the stencil operation to say, whatever we're drawing here, we want to draw the whole thing always. We don't want to clip it. We don't want to do anything with it. We want to just draw the geometry as is to the stencil buffer in its entirety. And to do that, we just use replace for everything and always, right? Next, we go ahead and we set the model matrix for the clip mask itself. And then we draw the clip mask geometry, right? So in our case, for the text box, it's just going to be a square, a box, right? Then we go ahead and we disable the write mask, right? So we don't want to write to the stencil buffer anymore. Now we want to test against it, right? So the next thing that we're going to do here is we're going to say, okay, we want to turn on stencil testing, set the compare mask, and then set the stencil op. So basically, if both the depth and stencil pass, unless depth is disabled, which it is, then we want to replace, meaning that we actually want to draw that geometry to the fragment shader, right? Or the image rather. And then otherwise we're going to keep it, right? And so we're going to say if the reference is equal, right? In other words, if we are within that that stencil, then we're going to go ahead and perform the draw on the next geometry, right? So if we do not have clip mask render data, we make sure that writing is off to the stencil buffer, and we turn off stencil testing, right? So in this case, we're going to consider this. We do have stencil data. We've drawn the stencil to the stencil buffer, and we've enabled testing against that stencil. So a little bit further down, we go ahead and we apply the local matrix there for the model matrix for that particular model, and or that particular geometry rather, and then we draw that geometry using the stencil test, right? And then once we've done that, we say, okay, well, if we had that clip mask render data, that means that we need to reset the stencil testing. So we go ahead and turn off stencil testing and set the stencil operation back to its default, which is this, right? So that's a lot. Totally recognize that's a lot. I can feel it in my voice that that's a lot, right? And so the last couple of bits of this are in our debug console, we added some really long test text into our text box that we had added in the previous stream. And then in the debug console visible set, if visible is true, it goes ahead and enables key repeats. If it's false, it turns them off, right? So whenever we bring up the debug console, it turns key repeats on. Whenever we hide the debug console, it turns them back off. So that's that. So SUI text box, we've added the clip mask here to the text box internal data, right? So that's that new structure that we have. And then within the text box control itself is our final piece of this logic, right? So what we do is we set up the text box clipping geometry. So the first thing that we do is we set a reference ID of 1. Now, this is not going to work if we have multiple text boxes, right? We eventually need to enhance this to generate a clip mask in a more global context and keep an ID counter, right? So that we can have a unique one. But it does limit us to 256, but honestly, if you have more than 256 clip masks, what are you really doing, right? I have questions at that point. So there's that. So let's see. So here we set up the geometry for the clip mask itself. It's just a simple quad, right? So all we do is we take the size of the text box and then we subtract from that the corner size. So we shrink it in so that it doesn't overlap the sides of the text box, right? And then for the height, we just use the height of the text box as our clipping mask, right? And so that's going to generate an area inside the triangle, or inside the text box, which we'll take a look here in a second and see what that looks like. And then we generate our geometry, and we set our clip mask render data. So we set all that up ahead of time, which we can do. We don't have to wait for render time to do that. We don't have a material. We use an identity matrix for now. Our unique ID is just copied over from the reference ID, and then vertex and index data. Diffuse color, and this is important, we set to vector4 0, which is completely transparent, because we do technically draw this to the fragment shader, but we draw it completely transparent so it doesn't show up, right? We may want to investigate a better way to do this, but for now that's how we're handling it. We go ahead and set the clips transform. So we set that position, right? So we just move that in by the corner size, right? So we move it in from the very edge of that geometry, just in a little bit. And then we go ahead and we parent the transform, right? So we've set that up. One change that we made was we had the content label childed to the text control, and we don't want to do that anymore because we actually need control over when this is rendered, right? So we've removed the logic that childs that, and instead of parenting it, we only parent the transform, right? So we still get the benefit of having the transform hierarchy, but we have control over when the clip mask gets rendered, right? So we go ahead and do that, and then I think all this is pretty much the same. So we set the transform position of the content label, and then we parent that, right? And then obviously set it active. Okay. So I added a couple comments in here as to what we're actually doing. We removed the cursor render because we don't need to render it twice. It's a child. So there's that. And then we attach the clipping mask to the text, which would be the last element added, right? So we would add the text at this point by rendering it, right? So this render right here adds it to the render data list. And then before any of the children of this get added, we want to say, okay, let's go ahead and attach the clipping mask. And so we push that onto the D array at this point, right? All right. So that's that. And I think that's actually everything for that change, right? That is everything. All right. So there are a couple more things that we actually need to briefly look at. Let me bring this back down. All right. So that's this one. This one we fixed a bug with dynamic state detection, which actually didn't fix the issue completely. It only partially fixed it. So yeah, we're going to revisit that, right? Konbanwa, Travis. Good evening, chat. Hey, Smudge. How's it going? Good to see you. Welcome to the stream. We're just kind of going over some changes here that were made sort of offline, right? Okay, so fixed some bugs around depth testing and dynamic state feature detection. So this is my second stab at this. This also wasn't right. And so I did fix a bug here where this was 0x4, which was a duplicate of something that already existed here, right? So this is functionally equivalent to this unless you tack a 0 at the end of it. That was fun. And then this we actually changed from stencil to depth. That was a copy pasta error. So we did actually fix that particular issue. And then last but not least, and this one looks massive, but it really isn't, right? So we added a minor check here. We only want to attach the clipping mask to the content label if the content label actually has text. Because if the content label does not have text, we don't draw it, right? So we don't want to draw the clipping mask either in that case. So we just added a quick check here for that. This is version. Debug console, I just fixed a couple minor things in here. I added a sample line here to prove the transform rotation. So we'll take a look at that in a second. Fixed an error message. Changed this 128 to the actual system type. Fixed another error message, right? So that's that. The Vulkan rendering backend is where we made a decent amount of changes. And it looks like a lot of change, and there is a lot of change technically, but a lot of it's actually deleting code. And so what I actually want to touch on first, if I could find it, is Vulkan types. So we had all of these various support flags, right? We had one for native dynamic topology, which is through extension, and then we had a separate one for dynamic front face, and then dynamic stencil and stencil. Like, all of these were basically based on dynamic state, right? You either had it or you didn't. And so we've actually changed this to just say dynamic state, right? So either we have native dynamic state or we have dynamic state, which is through extensions, right? And that's it. That controls all these other things. And then we have smooth line restoration, which is a different extension, right? And so those were condensed, which allowed us to condense a lot of our checks. We also, I also made the decision, because we had a lot of multiple pipelines and clockwise pipelines. So we had counterclockwise and clockwise variations of that based on a particular implementation of Vulkan not supporting the dynamic state extensions, right? And I've decided I'm going to terminate support for that. And the reason being is, macOS actually didn't require it. Molten VK handles it just fine. It was actually due to a logic bug that I had to have that stuff in the first place. So I didn't even need it for that. And I think anything that uses or has that particular issue is going to be on a really old version of Vulkan, is not going to support a lot of the advanced features anyways. And so probably could just use OpenGL at that point. And so we are going to just kind of say, okay, you know what? This is where I'm drawing the line, because we are going to wind up having to deal with dozens of pipelines here, which is completely ridiculous, right? So we've removed a lot of these pipelines. The clockwise pipelines, clockwise versus counterclockwise, winding order, that's dynamic state also. So we no longer are going to do this, right? We either support dynamic state or we don't, right? Dynamic state is very widely supported on 1.2 at this point. So we're saying 1.2 is what we're supporting with dynamic state. We're drawing a line in the sand right there, right? And so that is basically what this change is doing. So a lot of this is just going through and removing all of those extra flags, right? And we're essentially condensing all of this to say, do we support native dynamic state or regular dynamic state with extensions, right? So a lot of these logic changes in here are literally just changing those flags to look at those things and combining cases, right? So that's literally what all this is, right? And so we're able to eliminate a lot of flags and a lot of logic because of that, right? And so I'll go back here to the top. We have ads here in a second. So we'll be breaking here for a second, but this is actually the last piece of it, if you will, right? And then we can actually start looking at how this actually affects what we're doing. All right, we have ads. So I'm going to break the stream here. And for those of you that can still see me and hear me anyways, we like to break the stream for ad breaks. That way you guys don't miss content as it's kind of going on the screen there, right? Because I know Twitch kind of like puts it up in like the little corner and you can't read the text, you can't see what's on the screen, you can't understand what's going on because you can't hear me talking. So for those viewers, I like to pause the stream just to kind of handle that situation, right? And so I do remain here and I just kind of talk about random stuff. So if you guys have something in the chat you want to drop in there, you know, we can always kind of talk about it, BS back and forth for a second. And it also gives me the opportunity to get something to drink, which is awesome. So we've got about 40 seconds left. And then we can continue. We're actually making pretty good progress tonight. I didn't think we'd get through this quickly, so that's good. That's good. Almost there. And you guys on YouTube, let me know how the ads are working over there. If you guys are seeing ads or you're not, or whatnot, too. Because all of this setup is kind of new, right? Anyway, we are back. Let's see. Any reason you don't just run a pre-roll ad and then not run any ads during the stream? Surely you aren't making more than half a cent per ad. It kills the viewing experience flow of the stream. So once you are partnered on Twitch, you actually don't really have that option, right? Like ads are a requirement. You can choose how long they are, but yeah, it's you have to run ads basically. And I'm not a huge fan of like having like 8 minutes of ads, right? I feel like that's much more. Yeah, I'm partnered. Yeah. Sorry, affiliate. Partner is YouTube. But yeah, in order to be able to like use bits and all that stuff, you have to do that. There's not really a way around it, right? Coffee Lava, how's it going? Jesus Christ, it's soul foam. What did soul foam do, Coffee? All right. Anyway, so Vulkan backend is the last kind of bit of this, right? So we basically changed everything over to this dynamic state bit for our support flags. And then we've removed sort of everywhere else that was trying to swap pipelines on the fly, right? And so in this case, when we're doing a check like this, we say, okay, do we have native support for it? Use the native function. If we don't have that, use the extension function. And if we don't have that, you know what? You're SOL, right? There's just not much we can do for you. And so that's kind of the path we're taking going forward, because this isn't a situation I really want to support, right? Because I don't want to have to do this every single time, right? Because I'd have to have groups of pipelines and like multiple pipelines to support all this crap, because it's not dynamic, right? And I don't want to be swapping pipelines that often. Best chatter on Twitch, awesome. Affiliates on Twitch aren't forced to run ads though. Are we not? I'd honestly have to look at that, because I thought ads had to run no matter what, but maybe I'm misunderstanding that. I can look into it. I mean, ads do make me a little bit of money, but not much. You're right. It would be a lot different if, like, obviously I had a lot more followers, right? Speaking of which, follow me. Please. I appreciate you guys, regardless. Anyway, so most of these places, yeah, we're just changing over the flags here again, getting rid of ridiculousness like this. Again, the flags, more flags. Okay, so this is a section that we were able to simplify greatly, right? And so we basically had this thing to say, do we support, in this case I was saying dynamic topology, but really what it meant was dynamic state. Do we support that? If we do, we can use the simple case of only having 3 pipelines, right? Because you still have to have separate pipelines per topology class. There is no workaround for that, right? But otherwise, you can definitely... Sistema Futuro, thank you so much for the follow. Appreciate it. Welcome. And drop your Amazon Prime subs. Yeah, I mean, I would love if you did, obviously. Pog, right? But I appreciate you guys regardless. I just appreciate you guys being here, honestly. So we basically had this sort of simple case of saying, well, native topology is supported. We can just use 3 pipelines. Otherwise, we had to have a more complex class where we had to have 6, right? And that's times 2 because remember, we also had 2 sets of pipelines. We had pipelines and counterclockwise pipelines. And so we basically were able to remove all this crap, right? And say... one for the point class of topology, one for the line class, and one for the triangle class. And that's it. That's all the logic that we have, right? We don't have this clockwise, counterclockwise crap anymore. We don't have all these separate ones. Like, we don't do that anymore. And so we were able to simplify this a lot. And so for me, that's a worthwhile trade, I think. And so that was a sacrifice I'm willing to make. We are going to be, I guess, writing an OpenGL backend for this too, right? So if it really is an issue, you could just use the OpenGL renderer plugin instead, right? All right, so this is more flags. So that's pretty much it for that file, which is most of the pull request, right? Or most of the commit, rather. More flags. I was able to remove this completely, right? Because we no longer have to check whether this extension is included or not. We just include it here if the one flag is set, and that's it, right? And then I think we literally just changed the flags here. Yep. And the message here, right? To native dynamic state instead of talking about topology. So we have that. And then we just, instead of having to check for each individual one, all these sets of flags, we could say, okay, do we have to load up the extension functions? If we do, load this one, then load this one, then this one, then these guys, right? And that's it, right? Otherwise, if we have native support for the stuff, we just say, hey, we have native support for it. We don't have to do anything else, right? If we have neither, then we warn about it, but maybe the user is not going to do anything that requires any of this stuff. So we warn about it at this point, but we don't actually fail at this point, right? So this just says this may cause issues with the renderer, but we're not going to fail, right? Because we might wind up having something super simple that doesn't need all this stuff that we could just do in the meantime. So there's that. Yeah, and this is basically just whittling everything down to one flag, right? Oh, actually, I should point out here, I do this check first, which is for the native dynamic state, right? So we basically say, if our API version is greater than or equal to 1 and the API minor is equal to 2, greater than 2 rather. In other words, 1.3 plus, that's counted as having native dynamic state support, right? Because all that stuff became native at 1.3. Otherwise, if we actually support it by the support flag in extended dynamic state, then we go ahead and say we have support for it, but we have to load those things up, right? Yep, and that's it, right? That's the entire set of changes, right? So it's a lot, but it also at the same time it's really not that bad, right? So I think I built this already. Right, and so I'm going to run render doc just so that we can kind of see what this guy is doing. Right, and so if I open up the console here, we see our text box that it's clipped, right? It says some really long text, right? And I can move this cursor back and forth. And it's got this measure string stuff in it, right? That tells me how far within the string to actually do the thing. If we bothered keeping glyphs at each individual level within the text box, we probably wouldn't need to do that, but we're not going to have that many text boxes. I'm not really worried about it. This isn't a text editor application, right? I'm not really too worried about it. So we have the ability to do this, right? And this is actually clipped. So to make this a little easier to see, actually, let's load up a scene, right? So that you guys can see this in front of the text box, or in front of this guy, right? So we can see here, it is clipping exactly how we think it kind of should based on what we've looked at in the code, right? So what I'm going to do is I'm going to capture this frame and quit the application and show you guys exactly how this is working, right? So let me maximize this. And so what we're going to look at here is we want the render pass, right? The UI render pass. And if we take a look here, we can see that the first thing that we draw is this sort of background there. And then we draw this text here. And then we draw our text box background, right? That's our 9 slice. And then, we see something here and we haven't really drawn anything visible to the screen, right? But the very next thing that's drawn is our text. So this guy here is actually our clip mask. So if you look here, we actually have a second attachment here. So if we click on this guy, this is our depth buffer, or depth stencil texture, right? So right now we're looking at the depth aspect of this. And if we click over to stencil, we'll see that this is all black, right? And as soon as I'll go back here. As soon as like if I hover over this, right, we have stencil 0x00 here, right? We don't have anything, and it should be, looking at this image somewhere over here, right? And we don't see that anywhere. If we click on the next draw, notice we have that 1 there now. And it's going to be like next to impossible to see because it's just like shy of black, right? And so, but you can see there as I'm moving the mouse, like there's something there that's roughly in that shape that we expect. And so RenderDoc actually has a way to visualize this. So if we put overlay and then we do stencil test, we can actually see exactly where that is. And now if we right click and we hover over that, we can see, hey, look, that aligns with our stencil test, right? So this is where we actually draw to the stencil buffer, right? And you can't really see the stencil buffer here because it's a value of 1, which is very, very close to 0, which is black, right? And so if we continue on to our next draw call, still looking at the stencil, right? We could actually see this. And I used green and red when I was explaining things in my original drawing for a reason. And that's because things that pass the stencil test are in green, and things that fail the stencil test are in red. And those red things are not drawn. So what we're actually looking at here is our stencil buffer doing its thing. So if we switch back here, we can actually see that this perfectly overlays right where we saw our stencil test, right? So if we go back a step, this is where we're drawing our stencil, right? And that's exactly where we told it to draw, right? And here is exactly it doing its job, right? And so if we look at all this other geometry, it's all green, right? because there's nothing to test against, right? This is our 9 slice. This is our stencil object. That's our text, right? That's the only thing we're actually testing. And then the next thing is the cursor, right? Which it passes the test because there is no test. Then we have our geometry down here, right? Our test text here, our little object there, our button here, and then we end, right? And so combining all those things together, we can actually see that our clipping is working the way that we want it to. Now, again, you could be asking, why didn't we just use a scissor test for this? I'll show you. So if we open up debug console and we uncomment this line, this is going to rotate our text box on the z-axis, which is facing the camera, right? It's going to rotate that by 45 degrees, right? And I basically just went ahead and calculated the quaternion off camera ahead of time, just so that I would have something to sort of show you guys, right? And so if I go again, I'm just going to blow away that capture. And I'll bring this down. I'll load up the scene, move this up here so we can see, and bring up our debug console. Notice a couple of things. Our text box is rotated. Our text is rotated. Our cursor, which is here, might be a little harder to see for you guys on smaller screens. I'll do something better for the cursor in the meantime. But as we navigate that, it also is in relation to the text box, right? And so if I do a capture here of that frame and exit the application, now we can actually take a look at our render pass UI, and we can grab that overlay again for stencil test and see that our stencil is also translated. And so this is where stencil testing becomes super powerful, right? Is because we can draw any arbitrary shape at any arbitrary orientation and use that to clip geometry, right? Or use that to clip whatever it is we're drawing. And so it's super, super powerful that way. Yes, I see that you did the music there. So yeah, the music here is from Heartbound, which is a game in development by Pirate Software. So I'm going to I'll shout that out real quick. So it is basically it's a non-traditional RPG, and did that work? There we go. And so definitely give them a follow. His channel has like blown up lately for sure. But he's got some really cool stuff going on in his stream. He streams every day pretty much. So definitely give him a follow as well. But yeah, he was kind enough to allow me to use that music on my stream just to kind of give it a little bit of character, right? So cool. All right. So I hope all of this makes sense. That is pretty much the deal as far as what we're doing with stencils, right? That pretty much covers it. So, before we can kind of mark this text box as complete, there's one or two more things that I think we need to do. So let's go to we actually had sort of a to-do list here, right? So we've done clipping. We've done some of the navigation of the text box caret, right? So we've tied that to our arrow keys. The only thing that we're missing is the home end functionality. So we could add that really quickly to cross off that. We also need the ability to scroll left or right in the text box in overflow cases. So while we can move the cursor, we cannot currently go outside the bounds, right? So let me show you what I mean. So if we have this open, oops. Hit the wrong button there. Right, so if we have this open, if we have this open and I navigate, right, I could just kind of keep navigating off to the side. Now, I'm not clipping this. The cursor, you can kind of see it, it's right here. I'm not clipping the cursor because it's never supposed to leave the box in the first place, right? And so what we actually need to do is we need to translate this inner text object and the cursor relative to that, right? And I think the way that I'm going to do that is probably just move the actual text and then figure out what that offset is and offset the cursor by that much as well, and we should be good, right? So basically what I need to do is I'm thinking when I hit the last character here, or when I try to, anytime I actually try to scroll outside of it, if it's not the end of the string, we need to say, okay, are we outside the sort of clipping area, or would we land outside the clipping area? And if so, figure out what that difference is and move over by that much. And so that should handle that case, and that it should technically handle it in both cases. And I think that should give us what we need. So, you know, I can delete text, right? I can hold it down, delete it. I can type exit to exit the application, and it all works, right? Let me get rid of this. We don't need that anymore. We know that works, right? And so this is what we probably need to do next. And in fact, we'll probably do the home end functionality after that, right? Just as an easy way to sort of test this. And then finally, we'll need to have the ability to highlight text, and then have the ability to overwrite the highlighted portion of text. And then, of course, make sure that it's snapped within the viewport and all that stuff. Let's see. Lisp Gamer, cool stuff. Everything is written in C. Yes. The whole thing is written in C in its entirety. Yep. It absolutely is. Everything that you see within here, all these folders, all these things, it's all written in C. The engine included, right? All this stuff. What platforms do you compile for? Windows, Linux, and Mac OS. So we are supported natively on all three of those platforms. I do have plans to port this eventually to iOS and Android. I don't know when that's going to happen, but at some point. So right now I'm using Molten VK on Mac, but I do have plans to actually develop a Metal backend. So the way the engine is architected, is it allows for the renderer itself to be a plugin. So we have a Vulkan renderer plugin here, but we could just as easily and will create a OpenGL plugin, a plugin for DirectX, one for Metal, things like that. Yeah, so we'll eventually have all those things. But my goal is basically to, at least at the moment, I want to get it relatively feature complete with one API first before I actually port it to others. It's dynamically linked right now. Do you mean scripting language? So we don't have a scripting language yet. What we do have the ability to do is hot reload the game code. So the engine itself is a shared library. And then we have a couple of other shared libraries. The standard UI is what we're working on right now. The Vulkan renderer is a shared library. The testbed is an example of an application, right? The applications are super, super thin. And all they do essentially is they just load a series of function pointers from the application code, right? And so our testbed lib is the application code, right? And the reason it's split up like this is because this testbed lib is actually hot reloadable. So we can actually compile this and within reason hot reload that code while it's actually running, right? So yeah, I hope that makes sense. Let's see. So what do you mean add break? Let's see. So Lua. So, okay. So one thing I want to mention is, as far as a scripting language goes, the reason we don't have one yet is just because of the hot reloading. It's not to say we won't ever. The plan there is to also have the scripting language support as a plugin, right? So if the application wants to use that, the application can use it, but it doesn't have to. Like our standard UI is optional. You don't have to use that. You can use it if you want the predetermined set of controls, but you don't have to use it. Same goes true for scripting languages, right? So we might have one for Lua, we might have one for C#, right? And so the user can actually choose which one they want to use and use that one. Oh, it froze for a second. Okay. It says I've got a good connection, so maybe it's just a hiccup. Okay. Yeah, I think it might have just been a hiccup. Maybe there was a internet hiccup or something. So yeah, that's pretty much the way things are set up. Cool. All right. So the scroll left, scroll right business. Let's do. And actually, text view offset. This should probably be at F32, I'm thinking. So let's go into here where we're handling. Actually, we should probably write a method that could be called from a few different places, right? So we already have this calculate cursor position. And then we have update cursor position, right? Which calls that. So what we should probably do is before we actually set the cursor position, we should probably also check that it's within the bounds of the text box and scroll that if needed, is what I'm thinking. Just started playing around, but used to write a lot of OpenGL, but I'm learning Vulkan. Nice. That's awesome. Yeah, I've written a lot of OpenGL over the years too, and I've written a few different Vulkan renderers at this point, but this is by far the largest thing that I've written with it. So it's been a heck of a learning experience, that's for sure. It's worth mentioning something like C# is already able to interface with the engine rather easily. You'd need some kind of wrapper on the C# side, yep, and a small plugin for the engine to simplify the entry point. You did some testing, and you can already write a basic game testbed using C# and Kohi. That's pretty awesome. You've already tested that. That's pretty sweet. So one thing that I would be willing to do at some point is, and actually this has happened before, so if we look at the repo, right? It's open source, right? Apache 2.0 license. I don't think I mentioned that before. There are more than just me in here as far as contributors, right? There are people who have contributed small bug fixes and things. The largest contributor is Jad Taylor here, who actually wrote the initial pass for the Mac support, right? And I wound up refactoring a bunch of that to actually make it fit the sort of Kohi way of doing things, but credit goes to him with the original version of that, right? So for something like that, if the community wanted to write a plugin for that, I don't have a problem with that. The only reason that I have not done that so far is because the engine's still very much in its infancy, and I expect a lot of things to move around and break. And so that wrapper would constantly have to change, and that'd be a huge pain in the butt. But once we get to like closer to like a 1.0 release, I could definitely see that being a thing. So Smudge, if you have something that you've worked out, I figured you might. Yeah, I figured you might want to contribute to that. So, and you know, definitely, I make sure that credit it goes out where it's due, right? Like you'd show up as a contributor on there and everything. So, it's probably a little bit premature at this point, but yeah, once we get a little bit further down the road, definitely we could add that. The only thing being, I wouldn't want to, you know, that would be like an optional thing for game clients to use, right? I probably wouldn't have the editor use that, for example, right? We'd still write things like utilities or core Kohi things to not use that, but certainly we could have it set up so that you know, anybody that's using the engine to build an application could use it. I do have to think a little bit about how I want to handle plugins and plugin distribution, but yeah. Lisp Gamer, thank you for the follow. I appreciate that. Nice to chat. Ladies home from work. We'll be back. Nice. Alrighty. See you soon. Okay. So we're just kind of hard coding the Y, which is fine for now. But essentially what we're doing here is we've got this new position, right? This new position X. And we really should be sort of figuring out where that is in the string and if it's within the current bounds, right? So I guess that's probably what we could do. We could probably just do this in line. And then if we need to call it elsewhere, I can always separate it out into a function, right? So ensure the cursor is within the bounds of the text box, right? And so theoretically, we already have, let's see, when we create the clip mask, we are taking this, right? So this is essentially the size, right? So let's just paste that here for a second. And we're going to say F32 clip width is this, right? I guess we could do clip height too. We're not actually going to need it, but F32 clip height. If we ever do multi-line text boxes, we'll need this, but I'm going to go ahead and get rid of that for now. So we might, I think this is under typed data, end slice, corner size. Right. So that's the width, and then the F32 clip X is equal to type data actually, yeah, we do want to use the corner size X for this, right? So that's sort of the minimum that we do. So maybe we'll call it minimum. We'll call it clip X min, and F32 clip X max, right? And we'll say that is clip X min plus clip width, right? And so we could just do a min max check. So we could say if position.x is greater than clip X max, then we can say F32 diff equals position.x minus clip X max, right? And then we can set typed data, whoops, text view offset equal to diff. Obviously I can refactor this code to simplify it. I'm just kind of thinking out loud right now. So we can set the view offset to that, and then type data content label. We want to modify the X form of that. But we're already doing that down here. So actually all we need to do is position.x equals type data.text view offset. And that should move the whole thing. I'm not 100% sure that's right. Oh, and then we would need to do the cursor position itself. Oh wait, this is setting the cursor transform. No, this is wrong. So this should actually be position X should be clip X max, right? And then we should do transform position set. We want the address of type data content label X form, and the position is going to be type data. You know what? Let me just extract the position from this actually. Vec3 label position equals type data content label X form position. So we'll take a copy of that and we'll say label, or wait, no. So for X we want typed data text view offset. And then for Y, we want label position dot Y, label position dot Z. So we don't want to change those, right? So that's going to get us, I believe, extending past the end fixed, right? So it should kind of bump us over by a letter every single time. So let's test that first to make sure I'm not barking up the wrong tree on that one. All right, so I should be able to go here, right? And then once I go past the E, it should bump over a little bit. I did it once. Ooh, interesting. Okay, so there's like some sort of additive effect going on there. So it worked correctly the first time though. Calculate cursor position. So is this based off of the oh, we have ads. Ad break. So I'd just like to break the stream for a couple minutes here, just so that folks that are being served ads right now can not miss anything. So for those of you who aren't being served ads right now, feel free to jump in the chat if you have any questions or whatnot. We can talk about it. We don't take very long for it, but it's worth stopping in my opinion. So we got about a minute left, and then we can jump right back into it. I just realized the title is actually wrong on this stream. This is episode 148. And this should be... what do we want to call this? What did I call it on Twitter? That's actually a good... Bug fixes and stencils and clipping. Oh my. That's what I'm going to go with. Okay. Well, at least the stream data is correct, right? Or the stream name. Change it on YouTube as well. Perfect. Okay. And we are done with ads. So we're back. All right. So let's see. Why did we get that sort of weird... You know what, I'm going to close this other buffer. I don't need it. Why did we get that weird behavior? So calculating the cursor position. Let's see. I think all we're actually doing here is calculating how far it is away from the beginning of the string, which should be right. Although we're doing a mid-target. Oh, the string view offset is wrong. Okay. Because I wrote this differently than I'm actually going to wind up using it. So the length needs to be... string position minus string view offset. So it should be just string position. For that. So I was thinking the offset was going to be in characters, but it actually needs to be like sub-pixel units, right? Okay. I don't think that's going to solve the problem. Well, maybe it will. Let's find out. Zephra, hello, how are you doing? I'm doing well. Good to see you. Hope everything's going well. We're just kind of adding the finishing touches under our Textbox tonight. Well, I say finishing touches, they're kind of needed features, but we're pretty far along, I think. So let me see. So we get to here. So we bump over once, and then it goes back. Why does it do that? So I guess what we really should be this should be probably not called cursor position, right? This should be calculate cursor offset is what we should really call this. So let's go here. and call this offset, right? I'm also going to separate this guy out. Why did it? Okay. Let's grab that. And F32 offset. Right. All right, so this is the offset from the beginning of the string. And so we probably shouldn't even bother setting up this position stuff. Until after this, I'm thinking. Well, no, I could do it here. So this is going to be the sort of default, right? And this works until we actually scroll the text box. So where it breaks is in here. I'm doing good too. Are you a senior game developer in real life? I was for a number of years. Yeah, I don't currently do that, but yes, I was. What library do you use for F32 Vec3 types? So it's all my own library. This stuff's all written from scratch. Those type defs are my own. So if I go to definition, they're all here, right? So I've defined these in my defines header file. And I do some static assertions to make sure that they're the right size, right? And then I also have my own library here, which defines all of the various functions that you would need for like the vector functions and stuff like that. And those vectors are also defined in our math types here. F32 is a float 32, yep. It just helps me, that naming convention helps me wrap my head around it mainly when I'm like throwing stuff over to the GPU to keep them in my head, you know, how big the pieces of data are. I mean, I know off the top of my head, like float's easy, but some of the integers kind of can get to be a pain in the butt. So, plus it's a lot less typing. You know, if you type, you know, U64 instead of unsigned long, or unsigned long int, whatever you're using. Okay, so if our position now the cursor position should always be padded by this. So if that position is going to exceed the clip X max, which is this minus the padding, right? So that's the clip width. Clip max is the clip X min, which is this guy, plus clip width. So the min max, I think I've got those right. So the difference is position X minus clip X max, which in this case should never be negative, right? Because we've already said that this is going to be greater than that. So the first time we do this check, it works. So the type data offset is set to diff. Position X is clip X max. Position of the cursor. But then we also have to move the label. So the label position cannot just be the text view offset. That probably also needs to be padded, right? So instead of grabbing this repeatedly, F32 padding equals that, right? So I can just say this now. So the min is just going to be padding. The max is going to be the min plus the clip width, right? So if position X is going to exceed the clip max X, the differences between those, the offset should be the difference. That's how much we shift this by. Or should it be... Oh, maybe that should be negative. So we set the cursor right up against the edge. I think that's correct. But then translate the label backward. So this probably needs to be if that's never going to be negative, this probably needs to be, I could just flip this around actually. Position.x. So we set that. I think that's going to be, that seems right to me on this on the surface. Are you doing this game engine for fun, or is or it's for your job? So I have written game engines for my job before, but this one is, I guess you could say it's for fun, right? But it's also designed to be like a educational exercise. Like we're walking through all the steps from design and creation of it, from like file new project, right, all the way to eventually using this to build games, right? So the idea here is it's supposed to show the complete process of a way to build a game engine is basically what this is. Raz1789, thank you so much for the follow. Appreciate that. Welcome. VJ, hello. Welcome to the stream. Burn Sama, thank you so much for the follow. I appreciate that. Welcome to the stream. Hope you all are doing well tonight. Can't remember if I built this again, so I'm just building it real quick. And let me try running this real quick and see if our Textbox logic works. So I can go here, right? And the next one should shove the text box over. And it did. So if I do that one more time, it should shove it one more character. It didn't that time. Interesting. And now the cursor is jumping around. Okay. So it's like, it's a little bit more correct, but it's not fully there yet. So Raz1789, do you have your old devlogs archived in YouTube or somewhere? Yes. So let me actually show you guys something really quickly, because we've got a few new people here. So we have everything for this project is all outlined on kohiengine.com. So I'll drop a link here and in both chats, right? So we are actively streaming both on Twitch and on YouTube. This series basically began as a series, like a tutorial series on YouTube, and grew into this sort of live stream thing that we do on Twitch now. So if we check out the actual YouTube channel itself, we actually have a long playlist here, right? So let me actually click into this. So we have, well, this is going to show my view of it. So your guys' view will be a little bit different, right? But we have these playlists in here. And we have this, we have a devlog series, which is sort of like a synopsis of this. I've only done 2 of those. I'm really behind on that one. But the one you're going to want is this Kohi engine series, right? And so if I click into this guy, we have 153 videos in here so far, right? And so this started off in a tutorial format. So the first few dozen videos are that way. And then we eventually started right around here doing it live stream, right? And so everything that we've done live stream is part of this playlist on the YouTube channel. So everything we've done so far is all here. The entire project is open source as well, so it's available on GitHub. There's links there. It is open source. It's Apache 2.0 license, so the source is available to you guys. As soon as I finish it up here, I usually commit it, and if we're in a feature branch, I'll commit it there, like we're on the standard UI branch right now. And basically, yeah, this is all open source for you guys to use however you want. The only thing that I ask is, since it's Apache 2.0 license, I just ask that you credit me if you use it, right? Aside from that, there's also links on here, obviously the Twitch channel, Patreon to support me and stuff like that. We've got the actual live stream down here, so you can actually see me, several versions, little mini versions of me there. And then, you know, obviously the latest things. So all of that is there. We also do have API documentation. So this is auto-generated. So if you want to look through the individual data structures, or maybe files specifically, right? You can actually poke around in here and see, some of the auto-generated documentation that exists, right? Let's see. So yeah, just to finish up with that question, there are devlogs on here. I plan on doing a lot more of those. Those are just short synopsis videos of a section of the video. So I think I've covered the first 20 videos at this point in the series. So yeah, I am a little bit behind on those, but those are going to be coming as soon as I can get time to record them and edit them. Goat, thank you. Yeah, no problem. Following everywhere. I appreciate that. Thank you very much. What do you use for auto documentation? Doxygen? Yep, I use Doxygen. Exactly. Sorry for the... No, don't be sorry. So this is a interactive stream. So the whole idea is this is supposed to be a interactive and educational resource, right? So I want you guys to interact with me. I want you guys to ask questions. I try to keep a very open and welcoming environment here. We don't talk down about stuff. We don't think there's stupid questions here. If you have questions, ask them, and I'll answer them to the best of my ability. Right? Can you reply to my noob question, please? Which noob question? What do you mean by noob question? Oh, the static functions in C. Yes, I was getting to that next. So, generally speaking, when you use static functions, they are to basically localize this function to the context of this compilation unit. In other words, this C file. So what this basically means is that this isn't accessible anywhere outside this C file. And that's essentially it, right? So this is a way of just saying, let me think, what would the C# equivalent be? I guess it'd be like private, kind of, right? It's like private to this file. You can think of it that way. Yeah, it's private, essentially. Yep. Yeah. Welcome, Nopejar. Appreciate you being here. All right. Yeah, no problem. No problem at all. Like I said, if you have any questions, feel free to ask. Okay, so where did I go wrong? So the type to view offset. Zephyra, thank you so much for the tier 1 subscription. I appreciate that very much. Thank you very much. Appreciate that. Appreciate the support. And incidentally, any of the funds that I get for this, I try to reinvest in the channel, right? So either here or from YouTube. And actually, since I started, it was enough for me to actually be able to afford to get a Mac to port this platform to, or to port this to. So you know, anything that we any money that we make here, I try to reinvest into the channel. So I appreciate that a lot. Thank you very much. Oh, Raz, thank you so much for the Prime subscription. I appreciate that. Looks like there's a hype train potentially on the way. That would be the first one of the channel, actually. I've been streaming on here since the beginning of the year, and I think that's the first time I've actually seen it get close. So I appreciate that, guys. Thank you very much. Oh, hype train started. That is actually officially the first hype train on this channel. So big pog for that one. Thank you guys so much. Smudge, I appreciate the subscription renewal there for 3 months. Thank you so much for that. Greatly appreciate that. Oh, and it's at 93% too. Level 1 hype train. Awesome. Well, thank you guys for that. I really appreciate that. Like I said, even if it doesn't succeed, that's the first one I've had on this channel. So I really appreciate that, guys. Thank you very much. Incidentally, if you're looking to spend bits, we do have TTS on this channel. So that's one way you can use bits if you have them. Efforts are always noticed. Congrats. Thank you so much, Raz. I appreciate that very much. Okay, so so we set the cursor position, which seems to work. We translate the label backward. So we do that by taking the label position, setting the X of it, essentially. Which should be a negative value, right? Should be the diff. I wonder if we should, instead of doing this, I wonder if we should say 69 bits, nice. I think it has to be 100 bits in order for the TTS to go off. But I'll read it out, just in case, you know. My Rafflecopter goes soy, soy, soy. That's your manual text-to-speech right there. 69 bits, I like the number, by the way. How long have I been working with C? So exclusively, probably about almost 3 years now. I worked with C++ a lot before that, but all my C++ was very, I called it C++ light because it resembled C a lot. Like I used raw pointers and stuff like that, right? And so I'm just like, I hit a point where I'm like, why am I actually using C++ when my C++ looks like C, right? And so that's kind of when I made this switch, which was right before I started this project. This project's been going for about 2.5 years. What library would you recommend to use for people that want to start doing games in C? That's a good question. I think, can you use, before I answer that question, let me look up something real quick. Because I think I want to say you can use raylib. Yeah, it's written in C, plain C. That's what I thought. Yeah, so there's a good library called raylib. If you wanted to start kind of doing that and you didn't want to necessarily do everything from scratch like we're doing here, that might be somewhere to start. So yeah, I hope that helps there. But yeah, if you're, I mean, I'm not sure if you have C++ experience or not, because if you know C++, jumping to C shouldn't be that difficult. It's a lot simpler of a language. It's a lot lighter of a language. There's certain things that you don't have, like function and operator overloading, and namespaces, things like that, but okay. Incidentally, if you guys use, if you want, there's a guide on how to actually use TTS right there that I've linked in chat on Twitch. I don't know yet that it works on YouTube. I haven't had a chance to actually test it, so I don't know whether or not that'll work. But if you guys are wondering about all the options we have, I actually have some special voices and stuff hooked up to actually work through TTS. So, all right. Let's see. So I think I was going to change this to I'm going to do offset plus padding. Right, so if offset plus padding is greater than clipx max, then we're going to do maybe this is where I'm going wrong, right? So let me actually, whoops, wrong button. Let me actually move this up and say padding here. So padding plus offsets. So do I want to take away this, or do I want to take away that without the padding? This still feels right to me. If you want to use a map in C, do you import a library or do you code it? You code it. There is no map in C. There's no vector types or anything like that either. Yeah, doesn't include that. C doesn't have all that stuff. C doesn't have templates, actually, which is a good thing in my opinion. If I'm not mistaken, you can simplify the F. Yes, definitely. I'm namely just trying to figure out how to get it working first. The way that I need it to work. After you perform one offset, it seems to be wrong. And I just have to kind of figure that out. Because we should just be, like, reusing this every single time. Oh, wait a minute. This isn't accounting. I know what it is. Okay. So this also has to be plus the view offset. So typed data, text view offset, right? And this also has to be the same thing. Right, so type data offset. Right, so I might be able to use position X after all with this. So yeah, let's switch back to that. I think that might have been the problem. I think that might be it. It wasn't taking that into account after we shifted it once. It was basically zero basing it because we weren't doing it in the first place. So let's give that a shot. How is it calculating this? Like, that seems fine until I jump past it twice. And then it goes back there, which makes absolutely no sense. One thing I can turn off. Oh, wait a minute. Actually, ooh, this is wrong. That should be zero based. Oh, and I see something else actually that's wrong too. This is also wrong. String view offsets. Are we actually even using that anymore? Mid target, original length. Right, because I was originally thinking that we'd only like render part of the string or take part of the string into account. But that's not the way we're doing it anymore. This is actually completely wrong. So what we should do is change this to full string. Get rid of that. Which means we don't need this. I'm going to get rid of that too. Actually, maybe I'll keep that for a minute. We don't need... Oops. We don't need this. We should just need those two things. And actually, we don't even need string position. So actually, with all this, I don't even need this function at all. I can just completely factor that out. So let's do that. Data here and text here. Right, and then this font system measure string. Oh, wait a minute, I can't completely eliminate that. What am I doing? I just made a bunch of changes I can't actually keep. Oh, I do need that, but not all of it. I do need the mid. Technically, though, technically, I don't have a left function, do I? I really should write one of those. All right, I'll keep the mid. Annoying, but okay. I don't need string view offset. String mid is going to be destination, source, start, and length. So string view position is going to be the length. This should be 0 based. I'm going to delete that because it's wrong. Nope, Jar, thank you so much for the follow. I appreciate that. Let me see. Just check on chat real quick. Want to make sure not to follow behind on that. All right. So now this should be what we're looking at, because we basically want to measure the string from the left up to string position. Get that, return that. We don't need, let's see, the offset. We need type data, cursor position. We do need that. We don't need the offset is what we don't need. That should give us the 0 based offset that we need to calculate the rest of this. So the problem I don't think was here. I think the problem was here. Script CIBB. I'm not sure I pronounced it that correctly, but kind of a new C program here. How do you build your project? Which build system? Utilities, testing, also debugging. So what we do here is my editor here that I'm using is NeoVim, but I also do have this set up to work with Visual Studio Code. And so our build system here is basically, depending on what platform you're on, either a batch file or a shell script, right? So if you're on Windows, you're going to be using one of the batch files, and if you're on Mac or Linux, you're going to be using one of these shell scripts. Typically speaking, you'll want to do a debug build. This debug build reaches into the build all script that's by passing a couple flags. So if we take a look at this guy, we say build all.bat, and then we pass to that platform for Windows, build, and debug, right? And so when we look at our build all.bat, we do some detection in here, but ultimately we call make, right? So we just use the command line make. We have a make file, one for executables and one for libraries, right? And to that we pass the target and then the assembly, right? Which is just the assembly is the name of whatever it is that we're building. And the action is, build or clean or whatever it is, right? And the make file knows what to do with that. So we have make files that we're using to build everything. And we use Clang as our compiler. So if we take a look at the make file real quick, and go down here, we have, where is it? Probably should have just searched for it, but it's down here, right here. So we use Clang, right? And the reason I use Clang is because I can use the same configuration, the same files, the same build scripts, everything, cross-platform. And I could just tweak a couple of flags here and there based on what platform you're on in terms of what gets included and what gets linked. And it allows me to very easily do that. And now that I've got this system set up, I can very easily add a new executable and a new library, and it works, right? We have adds. So we'll break for that real quick, and then I'll come back and finish the explanation, right? So if you're not being served ads and you can still hear me and whatnot, I do like to break the stream up during ads, so that folks who are being served ads right now don't miss any content, right? And because of the way that Twitch works, if there is an ad slot that can be filled in your region, your locale, and the platform that you're on, it'll go ahead and serve you an ad. Some people get ads for the full 2 minutes. Some people get ads for like 30 seconds. Some people don't get ads at all, right? That's just kind of the way it works. So what we do is we kind of take the least common denominator for all of that, and we say we just break the stream for 2 minutes, and then we come back, right? And that way nobody misses anything. And so we've got about 40 seconds left on that timer, and it gives me kind of a second to catch my breath, if you will. So we got about 20 seconds left, and we can continue. So obviously, those of you who subbed don't see ads. So thank you for that. But, all right. We are back. All right, cool. So that is pretty much how our build process works, right? Because I can use the same make files. Isn't make Unix only? No, it is not. So there is make for Windows as well. Right here. All right, and I believe I put on the project page. Let me double check that. I think I put... it here, or let me pull this down so you guys can actually see it. I think I put it on this page, or did I put it on... I might have actually put it in the wiki. I know at the very least I did detail this early on in the video series. So if you actually take a look at this playlist right here, when we actually go to build the game engine setup in Windows, I actually go through the process of setting up make for Windows. Yeah, so it's all in there. So this whole playlist is all of the content up until now, right? Script, thank you so much for the follow. Appreciate that. Okay. So, I don't remember if I built this or not, but Radlife28, thank you so much for the follow. Let me just build this really, really quickly, and we can test our change. Hopefully that fixes it. All right, so... Debugging is basically just done through VS Code right now. I am testing some other external third-party debuggers, but I'm not comfortable with any of them enough to use on stream yet. So that's the reason I'm using VS Code for my debugger. You have to go. You really appreciate the time. See ya. See, yeah. I like what you did there. Yeah, and I appreciate you coming. I appreciate the support. So thank you for being here. See you later. Make wasn't added to the project until a little later, I thought. Pretty sure we just started with Clang, batch shell scripts, and... You might be right about that. I don't remember, to be completely honest. It's been a while since I've looked at those videos. I may have just done, like, raw Clang on the command line. In fact, you're probably right about that, yeah. At some point, we actually touched the build process a couple times. So, thank you, man. Appreciate it. Yeah, no problem. Yeah, like I said, we've refactored the build process a couple of times throughout the series. So, in fact, we're probably going to be doing it again sometime soon to get us down to one make file, right? So that we don't have two. All right, let's see. Oh, well, that obviously didn't work. It just jumped us all the way to the end. That's, you know, that's fine. Way too much. Perfect. All right, so what did we do here? So we should be taking into account the text view offset whenever we are calculating the cursor position. That makes sense. If we do that, clip x min. Maybe does this stuff need to be relative to it as well? I don't think it does. No, these should be fixed. So if position x is greater than clip x max, okay, so we still get the diff, that's correct. The text view offset, that maybe should not take the padding into account, I'm thinking. Make for Windows hasn't been updated since 2006, but there's no reason, it just works. Exactly, yeah, it just works. There's no reason to update it. So we set this, which seems correct, but this was foobar. Actually, did it set the cursor position correctly? No, it like jumped right to the end. Let me make sure that we're not setting that offset, because I know we had like a different idea of what it should be used for. Text view offset. We only have, okay, 3 macros, so we have them all on the screen. Cursor position. Update cursor position. All right, that's not particularly helpful. I guess I could search for that. So I don't think any of this logic is going to be incorrect down here. I think all of that is just going a character at a time, which is fine. So it's not any of that that's broken. It's literally older than Windows Vista, to put it to perspective. Yep, it is. Yeah, Windows Vista came out in... I think it came out... Did it come out in 2006 or 2007? I can't remember. It was like right on the border of those two, if I remember correctly. It was like during the holidays of 2006 into 2007, I think. I used to work at CompUSA right around the time Windows Vista came out. So it was 2006, 2007. I remember that. Because everybody that got it hated it. So, all right. Let me make sure that I didn't foobar this again. So string position. So the start should be 0. So measure from 0 to string position. That should give us the offset from the beginning of the string. right? That's what this is going to do. And then we return the X value of that. We save that off here. Padding. Then we say the position of X is equal to padding. So we take this, we move it over by the 9 slice. Then we take the offset from the beginning of the string. You know what? Let's just rename that so it's clear as to what it's used for. Plus the view offset, which can be negative. Should always be 0 or less than 0, according to this. So if cursor position X goes outside the bounds of clip X max, then let me actually get rid of this. So the offset is clip X max. That's not correct, I don't think. I mean, theoretically, we want to just get the distance and shift it by that. Oh, we want to shift it by that much. We want, okay. We want to shift it by that much. We don't want to set it. So this does need to be a different line. This does need to be diff, right? Because that needs to be different. This should be plus equals diff. And then we set it here. Looked it up, it was off by nearly a month. Technically, it released to manufacturers in November 2006. I thought so. But nobody basically got it till 2007. Yeah, that sounds pretty accurate. Make hasn't updated since November 2006. Six Windows versions later, it's still here. Yep. If it ain't broke, don't fix it. Hundo P. All right. Oh, it still goes to the end. Why are you going to the end? Why are you doing this to me? So it's literally measuring the entire string. Yeah, it's giving me the measure string for the whole thing. Did I screw up the mid? So we have destination, then source, right, which is full string. Then we have the start position, which is always 0. And the length, which is string position. String position is the first thing passed in. It's cursor position. So why is it giving me the full string? Oh, dumb. Because I'm measuring the full string. It should be mid-target. See, guys, we all make mistakes. We all struggle with stupid things. None of us are immune to it. Anybody who says they are is talking rubbish. All right. Now we can jump one character at a time. That's better. Okay, so after we jump to the E, it should snap to the end of that E. Went to the S instead, so that's neat. It looks like we might have gotten it, but we're off a character maybe? But it looks like we got it. But it looks like it's advancing too far. Yo-Yo Po, raiding with a party of 17. Thank you so much for the raid and welcome. Hello, raiders. How's everybody doing tonight? Your body is ready for Vulkan. Let me do a shout out. There we go. Thank you so much for the raid. What we're doing here is we are building a game engine from the ground up, completely from scratch, with a couple of minor caveats I'll get into in a second. And we're building the whole thing in C and Vulkan, right? And so we have a project here that's been underway for about 2.5 years at this point. It's called the Kohi game engine. It started as a game engine built as a YouTube tutorial series at the very beginning, and I've just been kind of trying different formats and working with different things, and I eventually discovered that live streaming it is the best way to go. So that's kind of where we wound up. And so all of the video archives are found on YouTube, and of course now we're live streaming both on Twitch and YouTube. So that can be found there. We've got a Discord with about 700 people on it. All of the everything we're doing here on this channel is completely open source. So the Kohi game engine is 100% open source. It's Apache 2.0 license, so anybody that wants to use it, you're free to use it for whatever you want to use, commercial, whatever. There's never any royalties, there's never any fees, there's nothing, right? And so you guys are free to use it as however you want. All you got to do is basically credit me. That's all I ask, right? And so, yeah, so far, we actually have a decent amount of things completed. We're working on a custom UI system that we're building from the ground up right now. And so I'm trying to solve basically stupid Textbox issues at the moment. But we're basically just in the middle of that. So, unfortunately, we were getting ready to tie up the stream for the night. So, you know, we're just kind of tying up for the night here, but I really appreciate the raid. So let me just catch up on chat real quick here. Yo-Yo 7 Tiger, I love it. I love the raid message. So what were you working on, Yo-Yo? Writing text boxes and raw Vulkan calls sounds like a nightmare. So what we've actually done in this engine is we actually have a sort of a plugin architecture for our renderer. So our engine is basically a shared library, and then we have what I'm calling the test bed, which is sort of our test runner application right now. And so we have our test bed application, that's our actual executable. And then we have the testbed lib, which you can think of as sort of the application code. And so the application itself loads up the application library, and that's hot reloadable, so we can compile that on the fly and make changes on the fly within reason. And then the renderer itself has a renderer front end that the engine knows about, right? So if we look in here, we have a renderer front end. And this is all the engine specific, this is the engine interface point, right? So this is all the engine knows about, is that there's a front end that I can interact with, and right? And as far as what's behind that, it doesn't know anything about it, right? So our Vulkan renderer is actually a plugin to the engine. And so it implements the backend calls to the renderer front end, right? And so the reason we chose this design is because we're doing Vulkan first, but we're eventually going to do DirectX, OpenGL, and Metal as other backends, and the application can actually choose which one it wants to use. And so we have a nice decoupled way of doing that. So the text box itself interacts with the renderer, and then those translations are made to the renderer backend. And that's basically how the whole engine works, right? So, oh, you are working in C#, nice. Are you coding your own driver, registry, interface, compiler, interpreter, etc.? No, as much as I would like to. But yeah, I just don't have time, unfortunately. Yeah, so there are a couple of things. There are a few things that I did take shortcuts on, right? So our engine does have some vendor code in it. I am using a library to load images and fonts, right? Just because I could spend weeks writing those things on my own, and there's not really a point, right? And we're going to have binary custom formats for both of these things. So once we have those, these will be eliminated from the core runtime, and that'll just be externalized to a tool set. But yeah, those are pretty much the only libraries I'm using, other than I am using OpenAL for our audio. And I have something to load MP3s and something to load Vorbis files. Again, there's not really a lot of value in rolling those from, on my own. But yeah, our audio plugin is also a plugin. So we have an OpenAL based audio system at the moment. You don't know about coding except Terry Davis. Nice. Yeah, he did do all that and more. He wrote his own programming language too. Stream defaulted to 360p. I was tabbed out and it looked like I was on LSD when I came back. Nice. No shame in using well-made libraries. Yeah, I'm making use of the STB libraries for loading files and stuff because Sean Barrett he's a Chad, for sure. So yeah, we do stream 2 nights a week right now is what I'm able to do, and I'm actually a little bit over on time right now, but basically I will be here tomorrow night as well, streaming. Where we'll pick up kind of the work that we've done. So, unfortunately, you guys have caught me kind of at the end of my stream. I was running over a little bit anyways. And so, yeah, I was just about to actually kind of wind that down and look for somebody else to raid. But, yeah, thank you guys for being here. I do want to drop a link here in chat real quick. So that is just a link to Kohi Engine. And the YouTube channel as well. And I would appreciate it a lot if you guys would drop some follows on here. I know several of you already have, so thank you for that. But yeah, if you guys go ahead and follow me, you'll get the notification when I stream next. And go ahead and check out my YouTube channel as well for all of the, sort of archived episodes of this so that you guys can kind of see where the project began all the way up until now. The YouTube playlist, I think, is up to 153 videos or something like that, with around 148 official episodes. So thank you guys for the follow. I appreciate that. Alrighty, so let me look for somebody to raid. I think tonight I'm going to raid another game dev here on Twitch, who's got a pretty sweet-looking game that he's making in Godot. And I'm going to go with Jitspo, because he's got a really cool-looking project. And, yeah, I would ask him to see what he has implemented with throwing books at things. It's kind of started off as a joke, but, like, he keeps implementing things where if you throw a book at it, it does something. So, I would ask him about that. And yeah, thank you guys for being here. I really appreciate it. And that's going to do it for tonight. So see you guys later.